Lawrence here. What I'm going to do today is I'm going to demonstrate rate of reaction between magnesium ribbon and hydrochloric acid. So I'm going to use gas pressure sensor here, and it's all linked to my laptop. First, I prepared hydrochloric acid serial dilution from 1 m, 0.5, 0.25 all the way down. Then after that, magnesium ribbon. I've got my magnesium ribbon here. I use sandpaper, polish it to remove away the oxide layer. So these are the magnesium ribbon, which is already polished. What we are going to do now is our research question is how will changing concentration of acid affect the rate of hydrogen gas production. So before we start, we do a simple test. Take a bit of hydrochloric acid out, put inside a test tube, add a piece of magnesium, strip in. Gas is produced, and this gas is hydrogen gas. So we're going to measure now the rate of hydrogen gas production. And how we're going to measure? We're going to use a gas pressure sensor. Change of pressure over time. That will represent the rate of reaction. So this is done. So we're going to run 2. We're going to start out with 0.5 m of hydrochloric acid. So this is my micro pipette. So I'm going to take 5 ml. 1, 2, 3, 4, 5. I've got 5 ml of 0.5 m hydrochloric acid. This is my magnesium ribbon. Strip, and before I put it in, I have to make sure that this is airtight. Yeah. So this is my screen capture. It's all linked now. Pressure currently is 101 kilopascal. Linked to vernier. The first thing now, get into data collection and make sure it's time based. Set it to 900 seconds. Click on OK. So you'll be a pressure against time for at least 900 seconds. So I'm going to click on the collect button. So start data collection first. So currently the base, which is the pressure, atmospheric pressure, is 101.36 kilopascal before I add magnesium strip, before the reaction starts. So I form a baseline. So the base is this, okay, atmospheric pressure before the reaction. So we're going to start the reaction now. So the reaction will start immediately when I add magnesium strip. So the pressure will start to build up. I'm going to add a magnesium strip, and immediately I'm going to put in the gas pressure sensor inside and make sure this is airtight. I'm going to throw in the magnesium strip now. Throw in. Pressure starts to build up. Pressure is increasing now from 101 to 111, 112 now, 113 kilopascal. And we are going to do a data recording probably for the first 100 seconds. Okay, we want to measure the initial rate of reaction. This is the initial rate. Because as the reaction proceeds, it will slow down as the magnesium is being used up. So we're going to measure the initial rate. So I'm going to stop the reaction after probably 90 seconds. Stop. Okay, I stop my data collection now. Done. This is done. So next, get into experiment. Store latest run. So I store my latest run. This will be reaction between magnesium strip with hydrochloric acid 0.5. So this is before the reaction starts. When I add magnesium strip, pressure starts to build up. So there's a change of pressure over time. This will represent the rate of reaction. Okay, this is where I stop the reaction, I remove it out, and pressure starts to drop. So I'm going to measure the gradient here. Okay, the gradient here. So I'm going to show you how you measure the gradient using sets of linear regression data. So I'm going to start a next experiment now. Same thing that I'm going to do. click on data collection later. Next, going to use lower concentration, 0.25 m. 0.25 m of hydrochloric acid, again 5 ml. 1, 2, 3, 4, 5 ml. Get ready my magnesium strip, and before I start, click on collect, and the reaction starts. So pressure is here. This is atmospheric pressure before I add magnesium strip. Okay, before I add magnesium strip. So what I'm going to do now is I'm going to wait. I'm going to wait until probably till about 50 seconds. Then I'm going to add in my magnesium strip. I'll get ready. Throw it in. Okay. Added my magnesium strip now. So this is the reaction between hydrochloric acid at a lower concentration with magnesium strip. So we're going to change the concentration of hydrochloric acid and see how it affects the rate of reaction. The rate of reaction is measured by change of pressure over time. At a lower concentration, of course, the rate of hydrogen gas production is lower, and is represented by the steepness, the gradient. Okay, the gradient. I'm going to show you now how we're going to measure the gradient. So we're going to stop the reaction at 90 seconds. So at 90 seconds, I'm going to release it, and the pressure will drop immediately. So at 90 seconds, I'm going to release it. 90 seconds, drops. So I click on stop. Okay, click on stop. Next thing now, I did experiment. Get into experiment. Store my latest run. So I have got two data now. So this one here, which is red in color, represent the reaction at higher concentration. This is at lower concentration now. So I'm going to use interval. Click on this interval here. Okay, highlight this part, this region. So I'm going to check now for this. Okay, the first one I'm going to look for. This is important. Where the reaction starts. So at time, this is 101. So when the reaction starts, so we got to look. And so the reaction starts at. I'm going to look for my data down here. So at 43 seconds. At 43 seconds, pressure is 101. So at 44 seconds, the pressure increased. So that is the point where I've added my magnesium strip. So I'm going to look for 44 seconds. So at 44 seconds, right? So this is at 44 seconds. So this is 44 seconds. So this part here, 44 seconds. So I'm going to look for 44. Seconds. Okay. So this is 44 seconds. And I'm going to highlight for the first probably 20 seconds. So 44 for the first 20 seconds. So it's 44, 45 plus 20 will be 65. So I'm going to highlight 65 for the first 65 seconds. Okay. So that is for the first 20 seconds. So I've highlighted it. Look for linear fit. So I'm going to click on, check on run 1. Run 1, which is my first run down here. So my first run, I click on OK. So I click on OK now. This will be for my first one. Not the one. So the steepness or the slope is 0.69 or 0.7. So that is the steepness for the first 20 seconds. So second one, I want to measure the rate of reaction for my second experiment now. So I get into my second data collection. So I check now when the reaction starts. Okay, when the reaction starts, I get back to my old data. So 101. So it starts at around, again, 44. Sorry, it's at 38. 38 seconds, the pressure starts to build up now. So what I'm going to do is click on here, look for 38. Look for 38. 38. Yep. So I got 38 now, and I'm going to get the first 20 seconds. 38 plus 20, that will give me 58. So I'm going to highlight till 58. Yep. Next, get into best fit. My second run. Click on OK. This will give me my second run. So this is my second run at lower concentration. So this is at lower concentration. At higher concentration is 0.7. At lower concentration, the slope, steepness of the slope is 0.17. So it seems like hypothesis is correct. Higher concentration, rate is faster, much more steep compared to lower concentration. So then after that, I've saved my data, so I get in the file and save it as under a file name. That's the end of this video. Thank you.